everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics Classes. This is Relations and Functions, Class 6. I am Sudhir MK. In this class, I am going to discuss about composite function. Consider a function f from a to b and g from b to c, then f of x equal to y and g of y equal to z. Here x is related to y by the function f and y is related to z by the function g. So we can write f of x equal to y and g of y equal to z. Then g of f of x, that is x is related to z by the function g composite f, which is called composite function. Now x is related to z by the function g composite f. So this is called as composite function. This is composite of g and f. Here x is related to z by the function g composite f. So now we say definition of composite function. So let f from a to b and g from b to c be two functions. Then the composite function of f and g denoted by g composite f and defined as g composite f from a to c given by g composite f of x equal to g of f of x. So this is definition of composite function. So g composite f of x is g of f of x. Now we consider a function f where x related to y by the function f. So we can write f of x equal to y. Here we consider one more function g, y is related to z by the function g and we can write g of y equal to z. Then x is related to z by the function g composite f. So here g composite f of x equal to z. So that is called as composite function. Now here we have two functions f and g. So x is related to f of x by the function f and f of x related to g of f of x under the function g. So therefore x related to g of f of x. So g of f of x is composite function of f and g. So next one note, f composite g of x equal to f of g of x and g composite f of x is g of f of x. That is composite function f composite g of x can be written as f of g of x and g composite f of x is g of f of x. So we consider some example. If f of x equal to 2x minus 1 and g of x equal to x plus 3, we have to find f composite g of 2 and g composite f of 2. Now first we find f composite g of 2. So that is f of g of 2. Now here it is given g of x is x plus 3. So therefore g of 2 is 2 plus 3. Therefore f of g of 2 is f of 2 plus 3. So that is f of 5. Now here it is given f of x is 2x minus 1. So therefore f of 5 is 2 into 5 minus 1. So 2 into 5 is 10. 10 minus 1 is 9. Therefore f composite g of 2 is 9. So next we find g composite f of 2. So it is g of f of 2. Now first we find f of 2. Now here it is given f of x is 2x minus 1. So therefore f of 2 is 2 into 2 minus 1. So that is g of 2 into 2 minus 1. So it is g of 2 into 2 is 4. 4 minus 1 is 3. So it is g of 3. Now here it is given g of x is x plus 3. So therefore g of 3 is 3 plus 3. So 3 plus 3 is 6. So therefore g composite f of 2 is 6 and f composite g of 2 is 9. Now here we can see f composite g and g composite f are not equal. Next we discuss problems and these problems are from exercise 1.3. Now first problem, let f from the set 1, 3, 4 to the set 1, 2, 5 and g from the set 1, 2, 5 to 1, 3 be given by f equal to 1, 2, 3, 5, 4, 1 and g 1, 3, 2, 4, 5, 1. Write down g composite f. Now here f function is given, g function is given, you have to find composite function, that is g composite f. Now here it is given f is 1, 2, 3, 5, 4, 1 and g is 1, 3, 2, 3 and 5, 1. Here it is given f is 1, 2, 3, 5, 4, 1 and g is 1, 3, 2, 3, 5, 1. So we have to find g composite f. First we write diagrammatic representation of this function. So here 1 related to 2 and 3 related to 5 and 4 related to 1. So here 1 related to 2, 3 related to 5 and 4 related to 1. And again 1 related to 3 and 2 related to 3 and 5 related to 1. Now you have to find g composite f, that is from first set to last set. So it is a function from first set to last set. So here it is 1 related to 2, 2 related to 3. So therefore we can write 1 related to 3. Now here 3 related to 5 and 5 related to 1. So therefore we write 3 related to 1 and here 4 related to 1 and 1 related to 3. So therefore we write 4 related to 3. So therefore here g composite f of 1 is g of f of 1, that is g of 2, that is 3. Now here in the function f 1 related to 2, therefore g of 1 is 2 and g of 2, 2 related to 3, therefore g composite f of 1 is 3. Same type g composite f of 3. Now g composite f of 3 is g of f of 3. Now 3 related to 5, so therefore f of 3 is 5. So it is g of 5 and 5 related to 1 under the function g. So therefore g of 5 is 1. So therefore g composite f of 3 is 1. So next we find G composite f of 4, and G composite f of 4 is G of f of 4. Now 4 related to 1 under the function f, so therefore G of f of 4 is G of 1. And G of 1 related to 3 under the function G, so therefore G of 1 is 3. Therefore G composite f of 4 is 3. So therefore we write G composite f is 1 3, that is 1 related to 3, and 3 1, that is 3 related to 1, and 4 3, that is 4 related to 3. Therefore G composite f is 1 3, 3 1, and 4 3. The next problem, find G composite f and f composite g if f from R to R and g from R to R are given by f of x is cos x and g of x is 3x square. Also show that G composite f not equal to f composite g. Here you would find f composite g and G composite f, and you would prove G composite f not equal to f composite g. Now here it is given f of x is cos x and g of x is 3x square. Now first we find G composite f of x. So G composite f of x is g of f of x. Now here it is given f of x is cos x. So therefore it is g of cos x. And here it is given g of x is 3x square. But in place of x you would write cos x. In place of x we have cos x. Therefore g of cos x is 3 into cos x whole square. So it is 3 into cos x whole square. Or it can be written as 3 cos square x. So therefore G composite f of x is 3 cos square x. So next we find f composite g of x. It is f of g of x. Now first we find g of x. It is given g of x is 3x square. So it is f of 3x square. Now it is of the form f of x, and it is given f of x is cos x. Now in place of x we have to write 3x square. So therefore it is cos of 3x square. Therefore f of 3x square is cos of 3x square. In place of x you have to write 3x square. So therefore f composite g of x is cos of 3x square. From equation 1 and 2 we can write G composite f is not equal to f composite g. Here G composite f of x is 3 cos square x and f composite g of x is cos 3x square, and they are not equal. Next problem, find G composite f and f composite g if f of x is mod x and g of x is mod of phi x minus 2. Now here also you have to find G composite f and f composite g. Now here it is given f of x is mod x and g of x is mod of phi x minus 2. Now first find G composite f of x. It is g of f of x, and here it is given f of x is mod x. Therefore g of f of x is g of mod x. Now here it is given g of x is mod of phi x minus 2, but in place of x you have to write mod x. So therefore it is mod of phi mod x minus 2. So therefore g of f of x is mod of phi mod x minus 2. So next we find f composite g of x, and f composite g of x is f of g of x. Now we substitute for g of x. G of x is given as mod of phi x minus 2. So therefore it is f of mod of phi x minus 2. Now here it is given f of x is mod x, but in place of x we have to write mod of phi x minus 2. So therefore it is mod of mod phi x minus 2, and it is same as mod of phi x minus 2. So therefore G composite f of x is mod of phi mod x minus 2, and f composite g of x is mod of phi x minus 2. The next problem, find G composite f and f composite g if f of x is 8x cube and g of x is x to the power 1 by 3. Now here f of x is 8x cube and g of x is x to the power 1 by 3. You have to find G composite f and f composite g. Now here it is given f of x is 8x cube and g of x is x to the power 1 by 3. Now first we find G composite f of x. G composite f of x equal to g of f of x. Now here we substitute for f of x. F of x is 8x cube. So it is g of 8x cube. Substitute for f of x. Now here it is given g of x is x to the power 1 by 3. But in place of x you have to write 8x cube. Therefore g of 8x cube is 8x cube whole to the power 1 by 3. In place of x you write 8x cube. So therefore it is 8x cube whole to the power 1 by 3. Now 8 to the power 1 by 3 is 2, and x cube whole to the power 1 by 3 is x. So therefore G composite f of x is 2x. So G composite f of x is 2x. So next we find f composite g of x. So it is f of g of x, and here g of x is given as x to the power 1 by 3. Therefore f of g of x is f of x to the power 1 by 3. Now here it is given f of x is 8x cube, but in place of x you have to write x to the power 1 by 3. So therefore f of x to the power 1 by 3 is 8 into x to the power 1 by 3 whole cube. So in place of x you have to write x to the power 1 by 3. Now here we have f of x to the power 1 by 3. So write in place of x to the power 1 by 3, we get 8 into x to the power 1 by 3 whole cube. Here cube and cube root get cancelled, remaining is 8x. So therefore f composite g of x is 8x. Now here G composite f of x is 2x, f composite g of x is 8x. So therefore here G composite f of x is 2x and f composite g of x is 8x. The next problem, if f from R to R given by f of x is 3 minus x cube whole to the power 1 by 3, then find f of x. Now here it is given f of x is 3 minus x cube whole to the power 1 by 3. You have to find f composite f of x. Now here it is given f of x is 3 minus x cube whole to the power 1 by 3. You have to find f composite f of x, and we can write f composite f of x is f of x. Now you substitute for f of x. F of x is 3 minus x cube whole to the power 1 by 3. So it is f of 3 minus x cube whole to the power 1 by 3. Again it is of the form f of x, but in place of x you have to write 3 minus x cube whole to the power 1 by 3. So we get 3 minus x cube whole to the power 1 by 3 whole cube, again whole to the power 1 by 3. So in place of x, you have to write 3 minus x cube whole to the power 1 by 3. So it is f of 3 minus x cube whole to the power 1 by 3 is 3 minus x cube whole to the power 1 by 3. Again whole to the power 3. Again it is whole to the power 1 by 3. Now here we can cancel 1 by 3 and 3. Remaining is 3 minus 3 plus x cube. Again 3 get cancelled. Remaining is x cube whole to the power 1 by 3. So remaining is x cube whole to the power 1 by 3. And here again cube and cube root get cancelled. Remaining is x. So therefore f composite f of x is x here. So next problem, consider f from n to n, g from n to n, and h from n to r. Defined as f of x is 2x, g of y is 3y plus 4, and h of z is sin z for all x, y, and z in n. Show that h composite g composite f equal to h composite g composite f. You have to prove h composite g composite f equal to h composite g composite f. Now here it is given f of x is 2x, g of y is 3y plus 4, and h of z is sin z. Now first we find h composite g composite f of x. Now here g composite f of x is same as g of f of x. So we substitute for f of x is 2x. So we can write h composite g of 2x. And here it is given g of y is 3y plus 4, and we can write g of 2x is 3 into 2x plus 4. So it is 3 into 2x plus 4. So it is h of 3 into 2x plus 4. So it is h of 6x plus 4. Now here it is given h of z is sin z, but in place of z we have to write 6x plus 4. So it is sin of 6x plus 4. So therefore h composite g composite f of x is sin of 6x plus 4. So next we find h composite g composite f of x. It is h composite g of f of x. So it is h composite g of 2x. Here it is given f of x is 2x. Therefore h composite g of f of x is h composite g of 2x. Now h composite g of 2x can be written as h of g of 2x. Again we write g of 2x as 3 of 2x plus 4. It is h of 3 of 2x plus 4 is h of 6x plus 4. h of 6x plus 4 is sin of 6x plus 4. So it is sin of 6x plus 4. Therefore h composite g composite f of x equal to sin of 6x plus 4. Now from equation 1 and 2 we have h composite g composite f equal to h composite g composite f. From equation 1 and 2 these two functions are same. So next problem, if f of x is 4x plus 3 divided by 6x minus 4 when x is not equal to 2 by 3, show that f composite f of x is x for all x is not equal to 2 by 3. Here we have to prove f of x is x for all x is not equal to 2 by 3. Now here it is given f of x is 4x plus 3 divided by 6x minus 4. We have to find f composite f of x. F composite f of x equal to f of x. Now here we substitute for f of x. F of x is 4x plus 3 divided by 6x minus 4. So it is f of 4x plus 3 divided by 6x minus 4. Now again it is of the form f of x, but in place of x we have to write 4x plus 3 divided by 6x minus 4. So therefore here it is 4 into 4x plus 3 divided by 6x minus 4 plus 3 divided by 6 into, in place of x you have to write 4x plus 3 divided by 6x minus 4 minus 4. In place of x we have to write 4x plus 3 divided by 6x minus 4. Now we simplify this, take LCM. So here LCM is 6x minus 4. When we multiply this, we get 16x plus 12. And here it is 18x minus 12 divided by, here also take LCM, it is 6x minus 4. Multiply this, it is 24x plus 18. And here it is minus 6 into 4 is 24x. And minus into minus is plus 16. Here 6x minus 4 get cancelled. And here 12 get cancelled. And here 24x cancelled. Remaining is 16x plus 18x. It is 34x. And in denominator it is 18 plus 16. 18 plus 16 is 34. And here 34 cancel. We get x. Therefore f composite f of x is x here. So next problem, show that f from r minus 7 by 5 to r minus 3 by 5 defined by f of x is 3x plus 4 divided by 5x minus 7, and g from r minus 3 by 5 to r minus 7 by 5 defined by g of x is 7x plus 4 divided by 5x minus 3. Then f composite g is IA and g composite f is IB, where A equal to r minus 3 by 5 and B equal to r minus 7 by 5. IA of x is x for all x belongs to A. IB of x is x for all x belongs to B are called identity function on set A and set B respectively. Now here two sets are given, A and B. A set is real numbers without 3 by 5 and set B is real numbers without 7 by 5. And here F is from B to A and G is from A to B. Here we have to prove that both composite functions are identity functions. Now first we find f composite g of x. So it is f of g of x. So it is f of g of x, and here it is given g of x is 7x plus 4 divided by 5x minus 3. So it is of the form f of x, and here it is given f of x is 3x plus 4 divided by 5x minus 7. But in place of x we have to write 7x plus 4 divided by 5x minus 3. So therefore f of 7x plus 4 divided by 5x minus 3 is 3 into 7x plus 4 divided by 5x minus 3 plus 4 divided by 5 into 7x plus 4 divided by 5x minus 3 minus 7. Here we take LCM, we multiply and simplify, we get 5x minus 3 LCM, and here we get 21x plus 12, and here we have to multiply these two, it is 20x minus 12 divided by, here also 5x minus 3 is LCM, and here we have to multiply this 35x plus 20, and here we have to multiply this 7 5s are 35x, minus into minus is plus 7 3s are 21. So here 5x minus 3 cancel, and here 12 cancel, and here 35x cancel, remaining is 21x plus 20x, so it is 41x divided by 20 plus 21, it is 41. So it is 41x by 41 is x. Therefore f composite g of x is x. So therefore f composite g of x is x implies f composite g is identity function. It is IA. F composite g is identity function. So next we find g composite f of x. So it is g of f of x. So g composite f of x is g of f of x. Now here it is given f of x is 3x plus 4 divided by 5x minus 7, and it is of the form g of x. And here it is given g of x is 7x plus 4 divided by 5x minus 3. But in place of x, you have to write 3x plus 4 divided by 5x minus 7. So we get 7 into 3x plus 4 divided by 5x minus 7 plus 4 divided by 5 into 3x plus 4 divided by 5x minus 7 minus 3. Now here also we take LCM. LCM is 5x minus 7. When we multiply this, we get 21x plus 28, and here also we have to multiply this, it is plus 20x minus 28 divided by, here also LCM is 5x minus 7, and multiply this, 5 3s are 15x, 5 4s are 20, here we have to multiply this, minus 3 into 5x is minus 15x, minus into minus is plus 21. And here 5x minus 7, 5x minus cancel, and here 28 cancel, and here minus 15x plus 15x cancel, remaining is 41x divided by 41, and 41 cancel, we get x. So therefore g composite f of x is x only. So g composite f of x is x, so implies g composite f is also identity function. So g composite f is identity function in set B. So therefore g composite f is identity function. So next problem, let f, g and h are functions from R to R. Show that f plus g composite h equal to f composite h plus g composite h, and f into g composite h equal to f composite h into g composite h. Now first we take f plus g composite h. We take f plus g composite h of x. Now f plus g composite h of x can be written as f plus g of h of x. Now this can be written as f of h of x plus g of h of x. It is f plus g of h of x can be written as f of h of x plus g of h of x. And this is same as f composite h of x plus g composite h of x. F of h of x is same as f composite h of x, and g of h of x is g composite h of x. And we can write this as f composite h plus g composite h of x. Therefore f plus g composite h equal to f composite h plus g composite h. Next we find f into g composite h of x, and it is equal to f into g of h of x. So it is f into g of h of x, and we can write this as f of h of x into g of h of x. So it is f of h of x into g of h of x. F into h of x can be written as f composite h of x, and g of h of x can be written as g composite h of x. So therefore f composite h of x into g composite h of x can be written as f composite h into g composite h of x. So it is f composite h into g composite h of x. So therefore f into g composite h equal to f composite h into g composite h. Show that f from A to B and g from B to C are 1 1. Then g composite f from A to C is also 1 1. Now here f and g are 1 1. You have to prove that g composite f is also 1 1. Now here it is given f from A to B and g from B to C are 1 1. We consider g composite f of x1 and g composite f of x2. And we can write this as g of f of x1 equal to g of f of x2. Here g composite f of x1 equal to g of f of x1, and g composite f of x2 is g of f of x2. Now here it is given g is 1 1, so therefore we can write f of x1 equal to f of x2. If g is 1 1, g of x1 equal to g of x2 implies x1 equal to x2, and here g is 1 1. Therefore here g of f of x1 equal to g of f of x2 implies f of x1 equal to f of x2. So since g is 1 1, here also given f is 1 1, so therefore f of x1 equal to f of x2 implies x1 equal to x2. Since f is 1 1, f of x1 equal to f of x2 implies x1 equal to x2. So we started with g composite f of x1 equal to g composite f of x2, and we get x1 equal to x2. Therefore g composite f is 1 1 function. G composite f of x1 equal to g composite f of x2 implies x1 equal to x2. So this implies g composite f is 1 1 function. So g composite f is 1 1 function. So that is, if f and g are 1 1 function, then g composite f is also 1 1 function. So next problem, show that f from a to b and g from b to c are onto. Then g composite f from a to c is also onto. Now here it is given f and g are onto. We have to prove g composite f is also onto. Now take z belongs to c, be any element. So take z belongs to c, be any element. So it is element of c. Since g is onto, there exists a pre-image of y belongs to b of z under g such that g of y equal to z. Now here it is given g is onto. For every element z belongs to c, there exists pre-image y in b such that g of y equal to z. Same type for y belongs to b, since f is onto, there exists a pre-image x belongs to a of y under f such that f of x equal to y. So here it is given f is also onto. So for every y belongs to b, there exists x belongs to a such that f of x equal to y. Then g composite f of x can be written as g of f of x. But here f of x equal to y. So therefore we can write g of f of x equal to g of y. But g of y equal to z. So therefore g of f of x equal to z. Therefore for every z belongs to c, there exists one x belongs to a such that g composite f of x equal to z. So therefore g composite f is onto. For every element there exists a pre-image under the function g composite f. So therefore g composite f is onto. So next problem, consider functions f and g such that g composite f is defined and is 1 1. So here g composite f is defined and it is 1 1. Our f and g are necessarily 1 1. You have to verify whether g and f are 1 1 when g composite f is 1 1. Now first we take one example. Consider set A with 1 2 3 4, set B with 1 2 3 4 5 6, set C is 1 2 3 4 5 6. Now here f of 1 is 1, f of 2 is 2, f of 3 is 3, f of 4 is 4, and g of 1 is 1, g of 2 is 2, g of 3 is 3, g of 4 is 4, g of 5 is 5, g of 6 is also 5. Now here in composite function, 1 related to 1, 2 related to 2, 3 related to 3, 4 related to 4. Different elements related with different images. In composite function, different elements related with different elements. So therefore, g composite f is 1 1. Now here f is also 1 1. Here different elements related with different elements. But g is not 1 1. So here different elements have same image. So therefore, g is not 1 1. Now here g composite f is 1 1 and f is 1 1, but g is not 1 1. Now here we consider f from 1 2 3 4 to 1 2 3 4 5 6 defined as f of x equal to x for all x, and g from 1 2 3 4 5 6 to 1 2 3 4 5 6 with g of x equal to x for all x equal to 1 2 3 4 and g of 5 equal to g of 6 equal to 5. Now here g composite f is 1 1 function but g is not 1 1 function. So here f is 1 1 function but g is not 1 1 function. So therefore if g composite f is 1 1 function, g may not be 1 1 function. Next problem, consider functions f and g such that g composite f is defined and it is onto. So here g composite f is defined and it is onto. Are f and g necessarily onto? You have to verify whether f and g are onto. Now here consider example, you consider set A is 1 2 3 4 and set B is 1 2 3 4 and set C is 1 2 3. Consider two functions f from A to B and B from B to C. Now here f of 1 is 1, f of 2 is 2, f of 3 is 3 and f of 4 is also 3. And g of 1 is 1, g of 2 is 2, g of 3 is 3 and g of 4 is also 4. Now here composite function 1 related to 1 and 2 related to 2 and 3 related to 3 and 4 is also related to 3. So here all the elements are images under the composite function. So therefore it is onto. So here g composite f is onto and g is also onto. But here f is not onto. Here f is not onto, g is onto. So therefore if g composite f is onto, g is onto but f is not onto. Now here we consider f from 1 2 3 4 to 1 2 3 4 defined as f of 1 is 1, f of 2 is 2, f of 3 equal to f of 4 equal to 3. Next we consider g from 1 2 3 4 to 1 2 3 defined as g of 1 is 1, g of 2 is 2 and g of 3 equal to g of 4 equal to 3. So here g of 1 is 1, g of 2 is 2, g of 3 equal to g of 4 equal to 3. And here g composite f is onto but f is not onto. So here g is onto but f is not onto. So therefore if g composite f is onto, f may not be onto. So g is onto but f is not onto. So next one, note. If G composite F is 1 1, then F is 1 1. If G composite F is 1 1, then F is 1 1. So if G composite F is onto, then G is onto. If G composite F is onto, then G is onto. F may not be onto. So that's all in this video. I will continue this chapter explanation in next video. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel, Aakruthi Mathematics Classes. Thank you once again.